distributing, also known as factoring. These both have a 2. Take it outside. So what do we have? 2 times, parentheses, sine squared x plus cosine squared x. And again, in brown, we have the big parentheses here. And then in brown, we still have equals 2. Final step here. No, okay. This is good. I'm so glad someone said it. Don't divide by 2. Because you can't touch this side. Remember, don't divide by 2. Replace sine squared plus cosine squared with 1. So replace this green and purple with a 1. So you'll have 2 times 1 equals 2. Don't leave it as this, even as baby math as this is, carry it out. 2 times 1 is 2. That equals 2. Put the... check. Call it a day. You don't have to. I just like a little flair. I think it looks nice to have a check mark. Brianna, what do you think? Questions? Diez 14. Is that right? No. That's 24, right? That. Oh my God. What did I say? What does that mean? There's no word? It means nothing? I'll tell you a funny story real quick. Yeah. Okay. So when I was in India once, I was going to I was in India and I was going from my grandparents' house to my friend's house, and so like I was like taking, I didn't have a car there, I don't drive there, so I was taking the cab, and I was taking the cab back, and my grandparents' address was this. So there's like if you were to like tell this to somebody, you would say like 3050. But I didn't know how to say 3050 in Hindi, so I said 3050 because like I didn't know how to say the whole word. So that's very similar to what I just did with the 14. I just said 10 4. Put it together. Okay, that was a bad. Maybe no like. Okay, anyways, let's keep going. No more stories. Okay. Okay, number 14, here we go. Okay, secant of x plus cosecant of x over 1 plus tan x equals cosecant of x. Again, you want to identify the complicated side. Again, it should be patently clear. Patent, good SAT word, means obvious. Then you want to identify which identities could be useful. So when I look at this problem, I see 3 possible identities. Please make sure you can get all 3. Let me freeze this. You should be able to write 3 possible identities when you look at this. And remember, the identities were emailed out to you yesterday, so if you are unsure which ones they are, it's all in your email. Please verify whenever you've got your 3, so you're getting what I'm getting. Now you want to say, how am I going to use these identities? Because remember, the goal is to make this complicated side equal to cosecant. So remember, our final answer will be cosecant of x equals cosecant of x. When I look at this left, more complicated side, unfortunately, there's no way to combine secant and cosecant, very obviously. And there's no way to combine the 1 and the tangent. There's no way to divide this fraction out. So in this case, and in some cases, you have to do this. You need to replace all of these with the identities you have here. It is oftentimes easier to write everything in terms of sine and cosine and then solve out. Not always, but oftentimes that is a helpful strategy. So I would just rewrite secant, cosecant, and tangent using the identities you have on the right. Okay. And hopefully you got this. So upstairs you have a fraction plus a fraction. Downstairs you have a fraction plus a fraction. You need to combine them into one fraction on the top and one fraction on the bottom. You can either use finding a common denominator or you can use the trick that I showed you. Either way, you'll get the same answer. So you got to combine these into one fraction, combine these into one fraction. Let's make it happen. Edgar, is everything all right there? Is that Edgar? Okay. So hopefully you got this. And then you want to do fraction divided by fraction. Everybody should know exactly what to do. Go ahead and make that happen. Before I do that, are there any questions on this much? So hopefully folks are at this spot. And now just take care of the algebra 1. And there you go. Questions on anything that was done? Questions? Okay. So let's individually focus on these two problems that I've circled in purple. scratch out number 9 yesterday? Okay. So, number 3 and 4 individually, and I'll be happy to take some questions. George, question.
We added the 1 cosine x plus 1 over sine x.
Where am I? Here.
Top.
Top?
Yeah. How did you get sine x plus cosine? Just get it like that.
Here?
Yeah.
Because we did bottom right times top left, that's sine.
Oh, you multiply on top.
Yep.
Oh.
Did this times this, that's cosine, divided by the trick, this times this.
When you crisscross multiply, that's when you add or it equals to each other?
So you cross multiply when one fraction equals another.
Oh.
This is just a little easy quick trick to combine two fractions into one.
So you can do that when you subtract it.
Yeah, subtract or add.
Can you say what you did for the denominator? The 1 over 1 plus.
Where am I looking?
Yeah.
Here?
Yeah.
Cosine times 1 is cosine. Bring the plus sign down. 1 times sine is sine.
Also, you
Cos
what?
times 1 is.
Like cross multiply something?
Yeah, so I don't want to use the term cross multiply. I want to use the term, I just want to say it's a trick, because cross multiplying implies you have one fraction equal to another. We actually don't have that, right? We're just combining two fractions that are being added into one fraction.
But why you like did the opposite if you added?
Because this is a trick. This is a trick that makes combining two fractions easier. It's just a different way to get a common denominator. That's all I did. If the trick is not working, just find the common denominator. It'll work the same way. Suddenly.
Can I see your proof?
Were you not here yesterday? Okay. So how did you do the problems we did yesterday in class? We did these. You didn't get those notes? There should be another copy on shelf 3. Hey folks, silently, I don't understand why there's a lack of clarity about the word silently. You should go to shelf number 3 or 4 to grab one. 3, 4, part 3. You're turning this up. I'm not coming Monday either.
Then I gotta carry all those 40.
This one, no. You grab whatever. This? Okay.